Another way that we can represent a relationship is with a graph. And let's see if we can tell whether or not a relationship is a function by looking at a graph. So this graph shows the relationship between the number of hours students spend studying for an exam and the exam grades. And so, as we would kind of expect, the relationship is positive because the more hours you study, the higher you expect your exam grade to be. And the question is the relationship in this graph a function? So let's remind ourselves the definition of a function. A function means each input has one output. We've previously looked at this as a mapping diagram and as a table, and one of the characteristics is that each x value has to have a unique y value. So if we look at this graph and we just start writing the coordinates here, let's just write the coordinates. So this one is 170. This one would be 270. This one would be 285. This one is 375. Boy, that 285 sure is irritating, isn't it? That's the kid that barely studies and still makes a pretty decent grade. This one looks like it's about 6 and, what do we say, like an 82 maybe? I'm just estimating, it doesn't matter. This is a 7 and you think like an 80, 88, we'll call it, 788. This is a 990. This is a 9 and a 95. And this person went nuts, 12 hours studying, and let's call that a 98. Okay, so there's all of our coordinates that we've got here. And if we were going to write this as a table, and I'm going to make a table because we already know how to identify a function from a table. If I were to write this as a table, my x coordinates, let's see, I've got, 170 was our first point, and then we have a 270. We have a 285, and we've got a 375, 580, 682, 788. We've got a 990, a 995, and a 1298. So if we took this graph and we wrote it as a table, this is what the table would look like. Now we've learned how to identify a function from a table, and that is we're looking for any x's that are duplicated, and we see some. We've got, ooh, too big. We've got this pair of 2's here. Get my highlighter. This pair of 2's right here. And we've got this pair of 9's. So this right here tells us it's not a function because we've got the number 2, that input of 2, that is assigned to two different outputs, 70 and 85, meaning we had two different kids that studied for 2 hours, but they made different grades. And then we have two different kids that studied for 9 hours that also made different grades, 90 and 95. So not a function. So let's go back to our graph and let's look at those specific pairs of points and see if we can tell just from the graph, because I don't want to have to write the coordinates and do this table to tell if it's a function. I'm going to be able to just look at the graph and tell. So let's look at those specific points, the 2's and the 9's. So here were the 2's, and then I'm going to use a different color for the 9's. Here's the 9's. And what do we notice about those points? Well, what I notice is that they're one on top of the other. I notice that these coordinates are right above each other. And in fact, that is how you can tell from a graph if something is a function or not, is if the points are stacked vertically, one on top of the other. And in fact, in math, we check to see if a graph is a function by doing something that is called the vertical line test. And the vertical line test is done by taking a straight edge, like a ruler, holding it vertically, so straight up and down, and we move the ruler across the graph, just left to right. And as we are moving the ruler across the graph, we ask ourselves, is there any point as we are moving this ruler across where it touches the graph more than one time? So we move here, boom, it's touching one point, that point at 170, that's fine. But when we go here, now it's touching the graph at 2 points. I can stop right there. It's not a function because it fails the vertical line test. Okay, so right here, oops, right at those 2 points, it fails, I'm going to abbreviate here, the VLT. Sounds like a delicious sandwich. Fails the VLT right there. I can stop right there. It's not a function. But let's keep going because we know there's another spot where it fails. Okay, here it touches 375. That's okay. Just 1 point. Just 1 point, 1 point, 1 point, and boom, there it is again. So right here at this point, at where our x is 9, it fails again. It fails the vertical line test. So there are 2 spots on this graph where it fails the vertical line test. And so what we would say for this is that it's not a function, not a function. It fails the vertical line test. And the vertical line test is what we call it, but the vertical line test is just a way of checking and saying, is there any spot on this graph that has the same x coordinate with 2 different y coordinates, which is, that's a giveaway that's not a function. If we have 2 x's inputs that have different outputs. Fails the vertical line test at x equals 2, and we don't need 2. We don't need 2 different spots where it fails. If it fails once, it's not a function, but this one just happens to fail twice, so let's include both of them in our answer. It fails at x equals 2, and it fails at x equals 9. If it just failed at one spot, it's not a function, but let's just make our answer as complete as possible and say, hey, it fails twice at x equals 2 and at x equals 9. Either one of those prevent it from being a function, so this is really not a function.